Welcome to this BeeGraphy tutorial. Today, we'll create a dynamic origami-inspired fold using BeeGraphy's design tools. Watch as simple shapes transform into complex forms by manipulating points and surfaces. The resulting model resembles a low pyramid or a diamond shape with creased folds extending inward from each corner toward the center. It's parametric because by adjusting the diameter and height sliders, the user can dynamically change the size and fold depth of the final origami shape in real time. We start by defining the key parameters of our fold. The diameter parameter, controlled by a range input node, will determine the overall size of our origami creation. Setting minimum and maximum values for the diameter allows us to explore variations in size and observe how the design responds. To calculate the radius, which is half the diameter, we use a division node, a powerful tool for mathematical operations within BeeGraphy. Now, let's lay the foundation for our origami fold. The Polygon node lets us create a variety of polygon shapes by specifying the number of sides and the radius. We'll use the explode node. This handy node deconstructs the polygon into separate curves, each representing an edge. Next, we find the precise midpoint of each curve using the curve middle point node. These midpoints are crucial for defining the crease lines of our fold. To create the fold effect, use the move node to displace the midpoints. This node lets you translate geometry in a chosen direction. A vector Z node will provide the direction and magnitude for the movement. To add further customization, we introduce a heights parameter using another range input node. This parameter will influence the extent of the upward folding motion. To achieve a balanced origami look, we want the opposite corner to fold downwards. Again, the division node comes in handy, allowing us to calculate half of the height value. To hide unnecessary geometries, select the corresponding nodes, right-click, and choose Hide. The List Item node is a versatile tool for accessing specific elements within a list. We use it here to isolate a single point from the curve midpoints, which will become the apex of our fold. The Vector X node defines the horizontal movement direction, allowing us to shift the isolated point along the x-axis. The opposite node then flips the sign of the result, providing us with a negative value for downward movement. Let's hide the unnecessary geometries again. To connect these key points and begin forming the folds, we employ the List Item node again to select another point. Let's hide the old points so they don't interfere with us. We use the centroid node to determine the center of the polygon. We use another move node to shift this selected point upwards using the same vector Z as before, ensuring consistency in our fold. Let's hide the old geometry so it won't interfere with us. Connecting all the moving points, we introduce the Polyline node, a powerful tool for creating lines that connect a series of points. This begins to define the actual folds of our origami shape. Clicking on the Boolean closes the curve. Let's move the inputs to the left so it will be easier to adjust the variables we need later. We use the Mirror node to create symmetrical geometry, mirroring the folds to complete the origami structure. The Plane XZ node defines the plane across which the mirroring will occur. We choose the XZ plane, resulting in a symmetrical fold across the vertical axis. To further enhance the complexity and visual interest, we introduce the Polar Array node. This node creates copies of geometry arranged in a circular pattern. Let's hide the old geometry so it won't interfere with us. We transform the curves into solid surfaces using the Curve to Surface node. This step adds volume and solidity to our origami fold. Apply material properties to the resulting surfaces using the Apply Material node to adjust color, roughness, metallicity, opacity, and material. We switch to the Configurator view to examine our completed origami fold. Thanks for watching. We hope this tutorial helped. For more on computational design, please like this video, subscribe to our channel, and hit the bell icon to get the notifications. See you in the next tutorial.